You know, for 4,500 years, the Great Pyramid of Giza has kept its secrets. It's the last wonder of the ancient world still standing, a structure so huge and so precise that people have seriously claimed aliens must have built it. But the real story? Oh, it's so much more impressive. It's a story about human smarts, clever physics, and some absolutely brilliant engineering. And today, using some brand new science, we're finally starting to figure out how they really did it.
Okay, so let's just start with a number that is almost impossible to wrap your head around. 6 million tons. That's the estimated weight of the Great Pyramid. I mean, to put that into perspective, that's like taking 10 of the biggest, heaviest skyscrapers in the world and squishing them all together into one single building.
So that brings us to the big one, the question that's bugged everybody for centuries. How in the world did a civilization working with tools made of copper and ropes made of plants build something that we would have a hard time making even today? This isn't just a big pile of rocks. It's a massive engineering puzzle.
So, in this explainer, we're going to put that puzzle together. First, we'll look at the mind-boggling numbers that made this seem like an impossible job. Then, we'll see how they figured out a genius way to move giant blocks of stone across sand. We're also going to bust a huge myth about what's actually on the inside of the pyramid. After that, we'll check out how cosmic rays are basically letting us X-ray the pyramid. And finally, we'll see the whole toolkit the engineers used to make it all happen.
So let's kick things off with the raw challenge itself. Before we get into the solutions, you really have to appreciate the sheer scale of the problem the ancient project managers were staring down every single day.
And this is where it just gets kind of crazy. You've got about 2.3 million stone blocks. You need to cut them, move them, and put them in place in about 20 years. If you do the math, that means that during every working hour, a new block, weighing an average of 2.5 tons, had to be set perfectly in place every 2 to 3 minutes. Think about that. Non-stop. The logistics are just breathtaking.
Okay, so you can't place a block until you get it there. And that brings us to the first gigantic problem. How do you move millions of tons of stone across the desert?
Well, believe it or not, a huge clue was hiding in plain sight for centuries in an old painting from a tomb. It shows this huge statue being pulled by a bunch of workers on a wooden sled, and right at the front, there's a guy pouring some kind of liquid onto the sand. For a long time, people just figured, oh, it's some kind of religious ceremony. Turns out, nope.
So let's look at the physics here. If you try to drag something super heavy across dry sand, it's a nightmare. The sand just piles up in front of the sled, creating a ton of friction. It's like trying to run through deep mud. You waste so much energy just fighting the ground. The effort you need is just immense.
But that guy pouring the water, he wasn't a priest. He was an engineer. By pouring just the right amount of water onto the sand, you don't make mud. Instead, you create what scientists call capillary bridges, basically tiny little water bonds that make the sand firm, and suddenly the sled can just glide right over the top with way less effort.
And the numbers don't lie. Look at this. To pull a standard 2.5-ton block on dry sand, it would take almost 13,500 newtons of force. But on perfectly wet sand, just over 6,100. That one simple, brilliant trick literally cut the number of people they needed for pulling in half. A 55% reduction in effort. It's a total game changer.
But wait, there's more. That's just for moving the blocks on site. What about getting them from quarries that were miles away? Well, just recently, using satellites that can see under the sand, researchers found something incredible. A 40-mile-long, dried-up branch of the Nile River that used to flow right up to the pyramids. This means they could have just floated even the heaviest granite blocks on boats almost all the way to the construction site.
All right, so we've pretty much figured out how they moved the stones. But that brings us to another huge myth we need to bust. The idea that the Great Pyramid is made of 2.3 million perfectly cut blocks, all fitting together like a giant Lego set. The reality is actually way more practical and honestly a lot smarter. As this research points out, while the outside of the pyramid had a beautiful, smooth casing of polished limestone, the inside, well, that's a totally different story. The core, the bulk of the structure, is just packed with rough, unfinished rocks of all different sizes, basically glued together with mortar.
And this wasn't some one-off trick they came up with. It was pretty much their standard way of doing things. You can see the exact same technique in older pyramids, like the bent pyramid.
It has a nice, finished outer shell, but underneath, you can see it's just a core of jumbled up stones held together with mortar. It's all about making the outside look perfect while being super efficient on the inside.
So why do it this way? Well, it's simple really. It all comes down to speed and efficiency. You save a ton of time because you don't have to perfectly shape every single block. You can use up all the leftover rocks and bits from the quarry, and putting it all in place is way faster. You're basically just filling in a space instead of trying to solve a giant, heavy puzzle. It saved them a massive amount of time and effort. Now, knowing that the pyramid has this complex, jumbled up inside makes you wonder, right? What else could be in there? For thousands of years, there was no way to look without just smashing a hole in it. But now we can actually use particle physics to see right through solid stone.
The technique is called cosmic ray muon radiography, which sounds super complicated, but think of it like this. Every second, tiny little particles from deep space, called muons, are raining down on us. They're so powerful they can pass through hundreds of feet of solid rock. So, scientists put these special detectors inside the pyramid. If a lot of muons hit the detector from one direction, it means they went through empty space. If fewer get through, it means they had to go through solid stone. It's basically a giant natural X-ray for a pyramid.
And this is one of the incredible images they got. The yellow and red areas, that's dense, solid stone, where not many muons could get through. But that big, bright blue area right there in the middle, whoa, that's a clear signal of a massive empty space that nobody in 4,500 years knew was there. I mean, this discovery was a bombshell. They named it the Scan Pyramid's Big Void. It's a huge space, at least 100 feet long, sitting right above the famous Grand Gallery. This was the first major new structure found inside the Great Pyramid in over a century, and they found it without drilling a single hole.
Okay, so we've got clever transport solutions, efficient building materials, and cutting-edge physics revealing brand new secrets. Let's pull all of this together and answer the final question. What was the real secret to building the Great Pyramid?
And the real secret is, there was no single secret. The genius of the Egyptian engineers wasn't one magic ramp or some lost alien technology. It was their incredible skill as project managers. They had a whole toolkit of different smart methods, and they knew exact which one to use for each stage of the construction. Modern engineers have looked at this and pretty much confirmed that at least 5 different theories are not only believable, but probably all worked together. They almost certainly used a mix of ramps, some outside, some inside. They may have used simple counterweights and pulleys. We know for a fact they mastered wet sand transport. And all of this was managed with a complex system of rotating work crews. The solution wasn't one thing, it was everything all at once.
But get this, the story is not over, not by a long shot. The Scan Pyramids project is still doing its thing, and a team led by the world-famous archaeologist Zahi Hawass is promising a new scientific report and some kind of major unveiling in 2026 based on what these new technologies are helping them find right now.
Which really just leaves you with one final amazing thought. The Great Pyramid was built right at the edge of what humans thought was even possible. For 4,500 years, it stood there as a monument to that ambition. And as our own technology finally catches up, we're learning to read its blueprints. So the biggest question now is, what other secrets is it still waiting to reveal?